So this short video is going to cover that second question that we had discussed in the linear inequalities, which is how do we deal with absolute value inequalities? So in order to solve and graph the absolute value of x is less than 5, what this is actually asking you is, how can I minimize the distance from 0? Remember that absolute value is a distance from 0. So if I want that distance to be less than 5, that means I could go as far down as -5 or as high up as +5. And all of these numbers in here, where I just drew my arrows, have a distance from 0 less than 5. So I want you to think about this next example. If I'm asking you to solve the absolute value of 2x minus 3 is greater than 5, I want you to think about what that looks like on a number line. What does it mean to be more than 5 units from 0 on a number line? Well, that means I can be at 5 and above, or from -5 and below. All of those numbers are more than 5 units from 0. So in order to solve this absolute value involving an inequality, the first thing you do is clear the absolute value bars by splitting this inequality into 2. Because if I want to be more than 5 units from 0, then that means 2x minus 3 could be less than -5, or 2x minus 3 could be greater than 5, thinking back to that visual that I just showed you. So you're going to solve them separately. We would add 3 to both sides here, and add 3 to both sides here, leaving us with 2x is less than -2, or 2x is greater than 8. And then we would go through and divide everything by 2, leaving us with x is less than -1, or x is greater than 4. Since both of these are just a less than or a greater than, they're just going to be parentheses on our number line. And if I were going to write that in interval notation, I would have from -infinity to -1, or from 4 to infinity. So let's look at 2 more examples. I want to start again with a less than. So if the absolute value of x minus 1/2 is less than 2, that means I want the distance from 0 to be no more than 2. That means I can go as far down as -2 or as high up as +2. So this is a nest. I'm going to drop my absolute value bars, and I'm going to go as far down as -2 and as high up as +2. And then I'm going to solve by adding 1/2 to each side, as opposed to a greater than. So if I'm going to look and I'm thinking about a number line again, and I want to maximize the distance from 0 because that's what a greater than means, and I want it to be more than 4, I can be from 4 up, or I could be from -4 down. So notice that the greater thans go in opposite directions, whereas the less thans stay in between 2 numbers. So I'm going to drop my absolute value bars, and I'm going to say that 3z plus 1 could be greater than or equal to 4, or 3z plus 1 could be less than or equal to -4. So notice one thing. Not only am I switching the inequality sign to be a less than, but I'm also switching that positive into a negative, because I'm maximizing that distance from 0. So a nice little summary to keep in mind is anytime I'm dealing with absolute value bars as well as an inequality, if it's a greater than or equal to, or a more, that's going to result in an or statement. If it's absolute value with a less than or equal to, I want you to remember that less means nest. So you're going to drop the absolute value and end up with something that looks like that. Okay? I'm going to give you a couple that I want you to try, and then if we need to go over this more in class, we certainly can do that.